All right, we'll go ahead and get started with the review for your first exam on Tuesday. Okay. All right, so the first problem is just solving a linear equation. Okay, so in problem number 1, we got 7 times the quantity x minus 8 plus 18 is equal to 3 times the quantity x minus 6. And here I want to solve this linear equation for the variable x. So the first thing I need to do here, on each side I need to remove the parentheses and combine like terms. Okay. So in this case, if I distribute the 7 over the x minus 8, that's 7 times x, that's going to be 7x. Minus 7 times 8, that's 56. Then bring down the plus 18, and then that's equal to. And if I distribute the 3 over the x minus 6, by doing 3 times x, that's going to be 3x. Minus 3 times 6, that's going to be 18. And then the next step would be to combine like terms here. And I'll have to do that on the left-hand side. So if I bring down 7x, what's negative 56 plus 18? And I get negative 38. So it'll be 7x minus 38. And that's equal to 3x minus 18. And then next I need to get all the variable terms on one side and the constant term on the other side. So what do I need to do to get the x's on one side? Let's subtract the 3x, and it would be best to remove or move the term or the variable that has the smallest coefficient over to the opposite side. So I'm going to subtract 3x on both sides. So when I do that, 7x minus 3x will give me 4x minus 38, and that's equal to, and make sure that you do bring down the minus sign in front of the 18. So that'd be negative 18. And what do I need to do here to get 4x by itself? Anyone? Add 38. So now we got 4x is equal to, what's negative 18 plus 38? So I got 4x is equal to 20, and what do I need to do to solve for x? Divide both sides of the equation by 4, so x is equal to 5. Now notice in that problem I didn't say check your proposed solution, but if you do have the time, it would be best for you to check your solution to see if it satisfies the original equation. So here x equals 5 is the solution to that linear equation. Are there any questions about number 1? All right, number 2. I'm going right down problem number 2. That's going to be x plus 8 divided by 5 minus x plus 4 divided by 2, and that's equal to 7/20. So here we have an equation that has fractions in them and pretty much numerical terms in the denominator. So that means we need to identify the least common denominator of those numbers that are in the denominator. And here we got a 5 and a 2 and a 20. So we need the LCD, or the least common denominator, for 5 and 2 and 20. Now keep in mind the least common denominator is going to be the smallest number that's divisible by 5 and by 2 and by 20. What would that be? Not 10. LCD. And it's got to be bigger than these three numbers or equal to one of those numbers, 20. Because 20 is divisible by 5, 20 is divisible by 2, and 20 is divisible by itself. So the LCD of those three numbers would be 20. And then the next step would be just to multiply every single term in this equation by 20. So this will be 20 times the quantity x plus 8 over 5 minus 20 times x plus 4 over 2. And that's equal to 20 times 7 over 20. Okay. And then the next step would be to simplify all of this. If I divide, for this right here, if I divide 5 into 20, that would go 4 times. So this will be 4 times the quantity x plus 8 minus, and if I divide 2 into 20, that goes 10 times. So this will be 10 times the quantity x plus 4. And then that's equal to, if I divide 20 into 20, that goes 1 time. I'm left with 7. So here I got 4 times the quantity x plus 8 minus 10 times the quantity x plus 4 is equal to 7. So here I can go ahead and remove the parentheses and combine like terms on the left side. So if I distribute the 4 over the x plus 8, what would I get? 4x plus 32. Now if I distribute the minus 10 over the x plus 4, I'll get what? Negative 10x is minus 40. Because that minus sign is going to be distributed, and that's going to change the sign of every term in the parentheses to the opposite. Okay? Now let's combine like terms. What's 4x minus 10x? Negative 6x. And what's 32 minus 40? Negative 8. So I got negative 6x minus 8. That's equal to 7. And to get negative 6x by itself, I need to do what? Add 8 to both sides. So now we got negative 6x is equal to 7 plus 8, that's 15. And then to get x by itself, I need to do what? Divide both sides of this equation by negative 6. So that means x is equal to, now this is going to give me an improper fraction of negative 15 over 6. But negative 15, 6 can be reduced to what? No, negative. What number can go into 15 and 6? 3. So 3 goes into 15 5 times, and 3 goes into 6 2 times. So here x equal negative 5 halves. And that would be my solution to this equation that has fractions in it. All right. Are there any questions about problem number 2? All right, number 3 has an equation where the variable is in the denominator. So number 3, we got 2x over x plus 3 is equal to 9 minus 6 over x plus 3. All right, in this case, we need to find out, and this on that problem, you'll have two parts. Part A, you have to find out what the restricted value is, and then part B, keeping the restricted value in mind, you're going to solve this equation. All right, so to find the restricted value, we need to find out what value of x that would give us a 0 in the denominator. And the only expression that we have in the denominator is x plus 3. So you're going to set that equal to 0 and find out what x is. Well, if x plus 3 is equal to 0, what must x have to be equal to? Negative 3. So I know at negative 3, I'm going to have a 0 in the denominator. And that will be my restricted value for this equation. And keeping that restricted value in mind, we're going to solve this equation. Well, of course, we need the LCD of our denominators here. The only thing we have in our denominator is the x plus 3. So that means x plus 3 would be my least common denominator. And from here, we multiply every single term in that rational equation by the least common denominator. So that means x plus 3 would be multiplied by 2x over x plus 3. And then that's equal to, then 9 would be multiplied by x plus 3. And then minus, now I'll put 6 over x plus 3 in parentheses. That's going to be multiplied by x plus 3. And from here, we just simplify this equation. On the left side, the x plus 3's divide out. All I'll be left there is, on the left side would be just 2x. And then that's equal to, now if I distribute the 9 over the x plus 3, what would I get? 9x plus 27. And then minus, for 6 over x plus 3 times x plus 3, the x plus 3's divide out. And you'll be left with 6. So I got 2x is equal to 9x plus 27 minus 6. All right, let's combine like terms if we can. So we got 2x is equal to 9x. What's 27 minus 6? 21. So I got 2x is equal to 9x plus 21. Now let's get the variable terms on one side of this equation. So here I need to move that 9x over to where 2x is by doing what? Subtract. You have to subtract 9x on both sides. So now we got 2x minus 9x, that's negative 7x, and that's equal to 21. And to get x by itself, I need to do what? Divide both sides by negative 7. And x will be equal to negative 3. Now, is x equal negative 3 my restricted value? In this case, it is, because here the restricted value was x equal negative 3. And when that happens, we have to eliminate that restricted value. And in this case, if you try to check your solution, you will get a 0 in the denominator. So that means that this rational equation will have no solution. And I will warn you, don't think that you're going to get a equation where the answer is going to be no solution. You will get an equation where your solution is going to be different from your restricted value. So do be aware of that. Are there any questions about problem number 3? Okay. All right, let's look at problem number 4. And in problem number 4, you're going to solve the quadratic equation using the square root property. And it does specify how we want you to solve that quadratic equation using the square root property in this case. So in problem number 4, we got 3x squared minus 147 equal to 0. 3x squared minus 147 equals 0. So in this case here, we need to get the x squared by itself. So what would be the first thing I need to do to get x squared by itself? Add 147 to both sides. So that means I have 3x squared, and that's equal to 147. And to get x squared by itself, I need to divide by 3. So that means x squared is equal to, what's 147 divided by 3? 49. So I have x squared is equal to 49. And then to get x by itself, what would be the opposite of squaring the x? Anyone? Square root. Anytime you take the square root on both sides, we must include that symbol, the plus or minus. So we're going to take the square root on both sides and include that plus or minus symbol. So that means square root of x squared is x, and then that's equal to plus or minus. What's the square root of 49? 7. So that means x squared is equal to 7. Now you can leave it like this if you want to, or you could write it as two separate answers. X equals 7, or x is equal to negative 7. And this is also acceptable as well. All right, any questions about problem number 4? All right, problem number 5 is solving the quadratic equation by completing the square. And here we got x squared minus 2x minus 5 equal to 0. All right, in this case, to complete the square, we need to move the numerical term over to the other side. So I'm going to move that minus 5 over to where the 0 is by adding 5 to both sides. So that means I have x squared minus 2x is equal to 5. And then the next step would be to just complete the square. All right, so here I got x squared minus 2x. Notice I'm leaving some space here for completing the square. Now when we complete the square, the way we do that is we take 1/2 of the coefficient of our x term, and then we square it. So in this case here, I'm going to take 1/2 the coefficient of x, which is in this case 2, and then square it. So what's 1/2 of 2? It'd be 1, and then 1 squared is 1. So that means I'm going to add 1 to the left side, and if I add 1 to the left side, I have to do the same thing on the other side. I have to add 1 to the right side of this equation. Because what's going to happen here is this will end up being a perfect square trinomial, which I can factor as the square of a binomial. So to do that, because I know I'm having a square here, the x squared would be x. This middle term has a minus sign, so I know I'm going to have a minus sign here. And if I took 1/2 of 2, that ended up being the 1. So that 1 goes right here. So this would be x minus 1 quantity squared. Now, of course, you can factor x squared minus 2x plus 1 as x minus 1 times x minus 1. You'll see that it'll end up as the square of a binomial. And then that's equal to 5 plus 1, which is 6. So I got x minus 1 quantity squared is equal to 6. Now, what's the opposite of squaring something? I got to do that first. What's the opposite of squaring something? Square root. So I need to take the square root of the left side and then include this plus or minus, and then take the square root of the right side. Now the square root of x minus 1 quantity squared becomes just x minus 1. Now 6 is not a perfect square, meaning that I can't take the square root of that number to get a whole number, so I will leave that as plus or minus the square root of 6. And now I need to solve for x by doing what? Add 1 to both sides. So this will be x is equal to, now these are two totally different terms. I can't combine those, so I'll just have to say 1 and then plus or minus square root of 6. Now you can write this as two separate answers if you want to, as 1 plus square root of 6. One plus square root of 6, and then 1 minus square root of 6. Okay. Those are my two solutions for this quadratic equation. Okay. All right, any questions about problem number 5? Okay, so make sure that you do follow the directions where it says solve by completing the square. Now, number 6 is solving the equation by using the quadratic formula. Okay, and in this case, you got x squared minus 13x plus 40 is equal to 0. All right, in this case, you want to make sure that you do have a 0 on one side of this equation before you use the quadratic formula. Okay, and in this case, we do. So that means I can identify what A, B, and C are going to be. The A is always the coefficient of your x squared term. That's 1. The B is the coefficient of x. That's negative 13. The C is the constant term. That's going to be 40. And of course, the quadratic formula will be this: x equal negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's the quadratic formula. And from here, we just do substitution here. We just substitute a, b, and c into that quadratic formula and simplify. So that means I have x is equal to, bring down the negative sign, replace the b with negative 13. So it'll be negative of negative 13 plus or minus the square root of b, again that's negative 13. That's going to be squared minus 4 times a, which is 1, times c, which is 40. That whole thing is divided by 2 times a, which is 1. Now let's simplify all of this here. Negative of negative 13 is 13, plus or minus the square root of. What's negative 13 and you square it? 169. Minus, what's 4 times 1 times 40? 160. All that's divided by 2 times 1, which is 2. And I'm still going to simplify what's underneath the square root symbol. What's 169 minus 160? 9. So I got 13 plus or minus the square root of 9, all over 2. And what is the square root of 9? 3. So I got 13 plus or minus 3 divided by 2. So this means that x is equal to 13 plus 3 divided by 2, or x is equal to 13 minus 3 divided by 2. Okay, now let's simplify this. 13 plus 3 would be what? 16. 16 divided by 2 is 8. Then for x equal 13 minus 3 divided by 2, 13 minus 3 is 10. 10 divided by 2 is 5. So here I've got two solutions for this quadratic equation. X equals 8 or x equals 5. And you can, if you want to, write it like this. And with the quadratic equation, you're supposed to have two solutions. X equals 8 and x is equal to 5. All right. Any questions on problem number 6? Okay. Now, problem number 7 is a radical equation, and this is the one you're going to need to check your proposed solutions here. And here we got the square root of 10 minus 3x equals x. So that's one of those equations that you must check your proposed solutions when you solve this equation. So here we got the square root of 10 minus 3x equals to x. And in this case, the radical is already by itself, so we don't have to worry about moving terms over to the opposite side. What would be the opposite of taking the square root? Square it. So we have to square both sides of this equation to eliminate the radical, or the square root, I should say. So I'm going to square both sides of this equation. So the square root of 10 minus 3x, and we turn around and square it, you'll be left with what's underneath that square root symbol, 10 minus 3x. And then that's equal to x, and you square it, will be x squared. Now we have a quadratic equation. So what we need to do here is to get a 0 on one side of this equation. So in this case here, I need to move some terms over, like the 10 and the minus 3x. I'm going to move that over to the right-hand side. So for the minus 3x, its opposite would be to add 3x. And that 10 is a positive 10, so I need to subtract 10. So that means I have a 0 on the left side, but on the right side, I have x squared plus 3x minus 10. So here I have a quadratic equation, which I'm going to try to solve for x. And pretty much I'm going to try to factor x squared plus 3x minus 10 into two binomials here. So I got the two parentheses here. X squared breaks up as x and x. Now let's think about this. What factors of minus 10 will give us 3x as a middle term? 5 and a negative 2. Okay, and it's going to be plus 5 and then minus 2 here because 5x minus 2x does give me 3x. And 5 times the minus 2 will give me minus 10. So I got x plus 5 times x minus 2 equal to 0. And then we're going to set each binomial factor equal to 0. So this means x plus 5 is equal to 0, or x minus 2 is equal to 0. And then for each equation, we're going to solve for x. So for the x plus 5 equal to 0, well, if I subtract 5, that means x is equal to negative 5. Or for the x minus 2 equals 0, if I add 2, you'll get x is equal to 2. So my two proposed solutions are x equal negative 5 or x equals 2. And one of them is the correct solution for this radical equation. So this is where you have to check your proposed solutions here. And I'll start with x equal negative 5. Now, using the original equation, I'm going to replace every x with negative 5. So I have the square root of 10 minus 3 times x, which is negative 5. And that's equal to, I want to know if that's equal to x, which is negative 5. Well, let's simplify what's underneath that square root symbol. Minus 3 times a negative 5 will be plus 15. What's 10 plus 15? 25. And what's the square root of 25? Does 5 equal negative 5? In this case, it doesn't. So here I have a false statement. So that means here, x equals negative 5 is what we call an extraneous solution, so I can cross that out. All right, but what about for x equal 2? So again, I'm going to substitute every x in the original equation with 2. So this will be the square root of 10 minus 3 times 2. Now I want to know if that's going to be equal to 2. All right, underneath that square root, 10 minus 3 times 2 is 6. 10 minus 6 is 4. What's the square root of 4? 2. And does 2 equal to 2? It does. So that means that x equals 2 is the solution for this radical equation. So with this, you must do the check on those radical equations. Are there any questions about problem number 7? All right, now problem number 8 is just solving the equation. Does everyone have this? All right, let's say we had this x cubed plus 12x squared plus 35x is equal to 0. And it just says to solve this equation. Here we just have a polynomial equation, which we can solve by factoring the left-hand side. So here we got a 0 on the right side, so we can just go ahead and factor this out completely. What is a common factor that's in x cubed, 12x squared, and 35x? x. We can factor out the x first. And to get what's inside the parentheses, we'll divide each term by that common factor of x. So here we got x cubed divided by x, which is x squared, plus 12x squared divided by x. That's 12x, plus 35x divided by x. That's 35, and that's equal to 0. And then for that x squared plus 12x plus 35, let's see if we can factor that out into two binomials here. X squared breaks up as x and x. And then what factors of 35 gives me 12x as a middle term? 7 and 5. And they both have to be plus because the middle term is a plus and the last term is plus as well. So factored out completely, I get x times x plus 7 times x plus 5 equal to 0. And then we set each individual factor equal to 0. So that means that this x will be equal to 0. The x plus 7 would be equal to 0. And then the x plus 5 would be equal to 0. And each equation we will solve for x. So that means here, well, x equals 0 is already solved for x. For the x plus 7 equal to 0, what must x have to be equal to? -7. And then for the x plus 5 equals 0, what must x have to be equal to there? -5. So for this polynomial equation, the solutions there would be x equals 0, x equals -7, and x equals -5. And the highest exponent is a 3, so I would expect to have 3 solutions for this polynomial equation. Okay. Are there any questions about problem number 8? Okay, problem number 9. Now, here we have an equation that has a rational exponent, meaning that the exponent is in the form of a fraction. So here you got 5x to the 3/2 minus 40 is equal to 0. All right, now before I attempt to solve this equation, I need to take a look at that exponent of 3/2. Because that's going to tell me whether or not I need a plus or minus symbol, and also whether or not I need to check my proposed solution. All right, the numerator tells me whether or not I need the plus or minus symbol. Is 3 even or odd? Odd. Well, if it's odd, that means I don't need that plus or minus symbol. Now, for the denominator of 2, is that even or odd? Even. When it's even, you must check your proposed solution. If the denominator was odd, then you don't need to check your proposed solution. Okay? So now, let's go ahead and solve this equation for x. So in this case here, what would be the first thing I need to do to get x to the 3/2 by itself? Add 40 to both sides. So we got 5x to the 3/2, and that's equal to 40. And then to get x to the 3/2 by itself, I need to do what? Divide by 5. So it'd be x to the 3/2 is equal to 8. X to the 3/2 is equal to 8. Now, what is the reciprocal of 3/2? 2/3. So that means I'm going to raise both sides of this equation to its reciprocal power, which is going to be to the 2/3. So that means I'll have x by itself, and then that's equal to, and this is just a to the 2/3, but here you can do this in the calculator by typing in the following. Just type in, let me clear this out, press the number 8 and then the hat key for your exponent. 2/3 will be 2 divided by 3, and then hit enter. It'll give you the answer of 4. So that means x equals 4 is my proposed solution. But for this problem, you are told with this, since the denominator was even, you do need to check your proposed solution. So that means I need to go ahead and do the check using the original equation and substitute the x with 4. So this will be 5 times 4 to the 3/2 minus 40, and that's equal to 0. Now, order of operations says we must do the exponent first. So 4 to the 3/2, that can be done in the calculator by pressing the number 4 key and then the hat key for the exponent of 3/2. That's 3 divided by 2. You'll get 8. So it'll be 5 times 8 minus 40 is equal to 0. And what's 5 times 8? 40. And what's 40 minus 40? 0. So this does check, which which means that x equals 4 is the solution to that equation with rational exponents. Okay. All right, are there any questions about problem number 9? All right, number 10 is using an appropriate u substitution to solve this equation. So here we got in number 10, x to the 4th minus 13x squared plus 36 plus equal to 0. Okay. Now this is where we use an appropriate u substitution for this problem. So in this case here, we're going to let u equal to whatever my middle term is. In this case, the middle term has x squared. So I'm going to let u equal to x squared. And then next to find out what, then I'm going to square both sides of this equation. So u squared will be equal to, here I'm raising a power to a power, so I multiply my exponents. It'll be x to the 2 times 2, which is 4. So u squared will be x to the 4th. So this is where I'm going to use the u substitution here. And in this case, this x to the 4th, that's going to be equal to u squared. So I'm going to replace x to the 4th with u squared minus, bring down the 13, replace the x squared with u. So it'll be minus 13u and then plus 36 equal to 0. So now I have a quadratic equation. Now that quadratic equation, I can find out what u will be equal to by doing some factoring here. Let's see. I'm going to factor this into 2 binomials. U squared breaks up as u and u. What factors of 36 will give me negative 13u as a middle term? Anyone? Would it be minus 9 and minus 4? Because minus 9u and a minus 4u gives me negative 13u as a middle term. So I get u minus 9 times u minus 4 is equal to 0. And then we set each binomial factor equal to 0. So this means that u minus 9 is equal to 0, or u minus 4 is equal to 0. And then for each equation, we're going to solve for for u. So for u minus 9 equal to 0, what must u have to be equal to? 9. Or for the u minus 4 is equal to 0, what must u have to be equal to? 4. Now do not end this problem right here, because it started off as an equation in terms of x. We must have our answers in terms of x. So this is where we do back substitution. Here we let u equal to x squared, so we're going to do the back substitution by replacing the u with x squared. So for u equal 9, replace the u with x squared. That means that x squared is equal to 9. Now what's the opposite of squaring something? Square root both sides. And include the plus or minus symbol. So we got x is equal to, what's the square root of 9? Well, plus or minus 3. So x will be equal to plus or minus 3. And the same thing here for u squared is equal to 4. That means we need to back substitute by replacing the u with that x squared. So x squared will be equal to 4. Same thing here by taking the square root on both sides, including the plus or minus symbol. What will be the square root of 4? Be 2. And x will be equal to plus or minus 2. Okay, so I have 4 solutions for this equation. X is equal to 3 and negative 3. X is equal to 2 and negative 2. And here the order doesn't matter for this. Are there any questions about problem number 10? Just solving an equation that is quadratic in form. And you have to use an appropriate u substitution for that particular problem. Okay, problem number 11 is solving an absolute value equation. And here we got the absolute value of 3x plus 5 minus 2 is equal to 6. Now the first thing I need to do here is get the absolute value by itself. So what do I need to do to get the absolute value of 3x plus 5 by itself? Add 2 to both sides. So I need to move that minus 2 over by adding 2. So here we have the absolute value of 3x plus 5. And then that's equal to 8. So now I have the absolute value by itself. That means I can go ahead and write my 2 equations here. So here the first equation would be just 3x plus 5 is equal to positive 8, or 3x plus 5 is equal to negative 8. And for each equation we will solve for the variable, solve for x. So starting with 3x plus 5 is equal to 8, what do I need to do first? Subtract 5. So that means I have 3x is equal to 3. Divide both sides by 3. X will be equal to what? 1. And then for the 3x plus 5 is equal to negative 8. To solve that, I need to subtract 5. So that means 3x is equal to, what's negative 8 minus 5? Negative 13. And then divide by 3 on both sides. I will leave this as negative 13 thirds. And I'll leave that as an improper fraction. Okay? So, the solution for that absolute value equation, I have two of them. X is equal to 1 and x is equal to negative 13 thirds. All right. Are there any questions about problem number 11? Okay, problem number 12. Now here we have just an inequality, linear inequalities here. So here we're going to solve the inequality and graph the solution set on a number line and write the solution set in interval notation. So with problem number 12, we got 3 times the quantity x plus 7 minus 12 is less than 5x plus 1. And here I want to solve this inequality. In other words, get the variable by itself. Now on the left-hand side, if I distribute the 3 over the x plus 7, what would I get? 3x plus 3 times 7, 21. Then minus 12 is less than 5x plus 1. Now combine like terms here. Let me bring down the 3x. 21 minus 12 is what? 9. So I got 3x plus 9 is less than 5x plus 1. Now when you're solving an inequality, it would be best to move the variable on the left-hand side. So I'm going to move the 5x over to where that 3x is by doing what? Subtract 5x. And when I do that, what's 3x minus 5x? Negative 2x. Then plus 9 is less than 1. And to get negative 2x by itself, I need to subtract 9. So negative 2x is equal to, less than, negative 2x is less than, what's 1 minus 9? Negative 8. So again, negative 2x is less than negative 8. And to get x by itself, I need to divide both sides by negative 2. When I do that, when I divide both sides of an inequality by negative, what's going to happen to this inequality symbol here? We're going to flip it from less than to greater than. So it'll be x is greater than 4. Okay? So it'll be x values that are greater than 4. Now it also says graph the solution set on a number line. And on your exam, you will have number lines on there so that way you'll be able to do your graphs. Let's see, I put 0 here. Now I put 4 there. Now at 4, do I need a bracket or parentheses? Parentheses, because 4 is not included. So I use a parentheses at 4. And notice that the inequality symbol points to the right That means I need to shade everything to the right of 4, like this. That would be the graph of the solution set. And then next would be to write this in interval notation. Well, 4 is not included, so that means we use the left parentheses at 4. This goes indefinitely to the right, so we use infinity. And with negative and positive infinity, we always use parentheses. Okay. Are there any questions about problem number 12? All right, problem number 13 is, again, solving the inequality graph, the solution set on the number line, and then write the solution set in interval notation. This time, we have a compound inequality. And in this case, that's negative 2 is less than or equal to 3x plus 4 and less than 6. In this case, we have to perform the same operation on the left side, in the middle, and on the right side of that compound inequality. So we need to isolate the variable that's in the middle. What would be the first thing I need to do here? Subtract 4 from all 3 sides. So, on the left side, where this negative 2 is, I'll subtract 4. In the middle of this inequality symbol, subtract 4. And on the right side, where the 6 is, also subtract 4. Okay, because it is a compound inequality, you have to perform the same operation on all 3 sides. The left side, the middle, and on the right side. What's negative 2 minus 4? Negative 6. That's less than or equal to 3x. And less than 6 minus 4 is 2. And now to get x by itself is being multiplied by 3, so I need to do what? Divide by 3. The left side I need to divide by 3. The middle, divide by 3. The right side, divide by 3. So here negative 6 divided by 3 is negative 2. And then that's less than or equal to x, and less than, we'll just leave that as positive 2/3. So this is my solution set for this compound inequality. X is greater than or equal to negative 2 and less than 2/3. And it also says graph the solution set on a number line. So negative 2 is to the left. I'm going to say 2/3 is right here. Now at negative 2, do I need a bracket or parentheses? A bracket, because it has a less than or equal to sign. What about the 2/3, bracket or parentheses? Parentheses, because the 2/3 is not included. And to indicate that all the values of x are in between negative 2 and positive 2/3, I shade in between those two. Okay. So the interval notation for that would be this. A bracket for the negative 2, and then for 2/3 we use a right parentheses. So that would be the solution set, or the interval notation for that solution set. Negative 2, 2/3. Negative 2 is included, but the 2/3 is not. Are there any questions about problem number 13? Okay, problem number 14. is absolute value inequalities. Well, 14 and 15 are absolute value inequalities. So here in 14, you're going to solve the absolute value inequality and graph the solution set on a number line, then write the solution set in interval notation. So here we got absolute value of 3x minus 1. Is greater than or equal to 5. Well, notice we already got the absolute value by itself, so we don't have to worry about moving terms over to the left-hand side. To the right-hand side. Now, that inequality symbol is going to tell you how to write your absolute value inequality. Since it's greater than or equal to, and that also true for greater than, we can write this as two separate inequalities here. The first inequality would be 3x minus 1 is greater than or equal to 5, and then the second would be 3x minus 1. We switch this inequality symbol from greater than or equal to less than or equal to. Positive 5 becomes negative 5. So those are our two inequalities here. This is only for greater than or equal to. Each inequality will get x by itself. So for the 3x minus 1 is greater than or equal to 5, first step would be to add 1. So that means I have 3x is greater than or equal to 5 plus 1, which is 6. And then divide both sides by 3. X is greater than or equal to 2. Or for the 3x minus 1 is less than or equal to negative 5, you'll still add 1 to both sides. So that means 3x is less than, what's negative 5 plus 1? Negative 4. Divide both sides by 3, you'll get x is less than or equal to, and I'll leave this as negative 4/3. So my solution set would be x is greater than or equal to 2, or x is less than or equal to negative 4/3. And with this, we're going to graph the solution set on a number line. And again, you'll have number lines to use to graph your solution sets on the exam. I'll say negative 4/3 will be over here somewhere. Positive 2 will be over here. Now for x is greater than x is greater than 2. Greater than or equal to 2. At 2, do I need a bracket or parentheses? Bracket. And of course, it says greater than. That means the greater than symbol points to the right. We shade to the right of 2. Like this. And then for x is less than or equal to negative 4/3, at negative 4/3, do I need a bracket or parentheses? Again, a bracket. Less than, that symbol points to the left. We shade everything to the left of negative 4/3. So that's the graph of the solution set. Now to write the interval notation for this, we're going to go from left to right. So starting from the left-hand side, that's negative infinity, goes on indefinitely. So it's negative infinity to negative 4/3 with a right bracket. And then we use this symbol for the union of the two. This other one, from 2 on to infinity. 2 has a bracket there. Infinity to the right. With negative and positive infinity, we always use parentheses. Any questions about problem number 14? And finally, problem 15 is where we have to solve the absolute value inequality and graph the solution set on a number line, write the solution set in interval notation. In this case, it's the absolute value of 7x minus 5. is less than 9. Now, number 14, with greater than or equal to, you had to write that as two separate inequalities. With less than or equal to, we're going to write this as a compound inequality for this absolute value inequality. And the way we set up that compound inequality would be this. What's inside the absolute value symbol, which is, of course, 7x minus 5, will be in between the two less than symbols. On the left side, your 9 would be negative. On the right side, the 9 will be positive. So here we got 7x minus 5 is greater than negative 9 and less than 9. So here, like we saw that compound inequality in number 13, we're going to perform the same operation on the left side, the middle, and the right side. So in this case here, to get the x by itself in the middle, I need to do what? First, add 5. Add 5 on the left side, add 5 in the middle, and add 5 on the right side of that compound inequality. So what's negative 9 plus 5? Negative 4, and that's less than 7x, and less than 9 plus 5 is 14. And now I still need to get x by itself. I'm multiplying it by 7. I need to do what on all three parts? Divide by 7. The left side, the middle, and the right side I divide by 7. This will still be, well, I'm going to leave that as negative 4/7, and that's less than x, and less than 14 divided by 7 will be 2. So in this case, I have x is greater than negative 4/7 and less than 2. Now we're going to graph the solution set on a number line that will be provided for you. You see 0 is here, negative 4/7 is somewhere over here, and 2 is here. Now for negative 4/7 and for 2, do I need brackets or parentheses? This time parentheses. They're both strictly less than. So a left parentheses at negative 4/7 and a right parentheses at 2. And to indicate that all the x values are in between negative 4/7 and 2, we just shade in between, like this. So that would be the graph of that solution set. Now for the interval notation, of course, left parentheses for negative 4/7 and a right parentheses at 2. That will be my open interval for the graph for this solution set of this absolute value inequality. All right, are there any questions about problem number 15? Or does anybody have any questions about what will be on exam number 1 on Tuesday?